Hello everyone, I am Mohammad Ahmad Qureshi, working as an assistant professor in Civil Engineering Department at RNG Patel Institute of Technology, Bardoli. In the previous lecture, we had studied design of structure subject and in which we had gone through analysis of doubly RC beam. Now, in this lecture, we will study the design of doubly RC beam. So, firstly, we have to design for tensile and compressive reinforcement in the design procedure of WRC beam. So, in the first example, it is given that find the area of tensile and compression reinforcement. We have to find the area for tensile steel as well as for compressive steel required for a rectangular beam of 300 mm into 500 mm, 550 mm effective. Means here 550 mm is given as effective, means small d. So here from the given data, we may say that width of the beam is given as 300 mm and the effective depth is given as 550 mm. For the factored moment of 400 kilonewton into meter. Here mu is given as 400 kilonewton into meter and effective cover for the tensile and compression steel are 50 mm and 40 mm respectively. For the tensile, the effective cover is 50 mm and for the compression steel it is 40 mm. Use M20 and Fe415 grade of steel. So, firstly, we have to calculate the area of tensile and compression steel. Now we will go for the given data. So here FCK is given as 20 Newton per mm square. Fy is given as 415 Newton per mm square. Now, as the moment, factored moment is given as 400 kilonewton into meter, so we will write mu equals to 400 kilonewton into meter, which will be equals to 400 into 10 raised to 6 Newton into mm. As all data are with respect to Newton and mm, so we are converting kilonewton into meter into Newton into mm. Now, as the characteristic strength of steel is given as Fy equals to 415 and for Fe equals to 415 we have the equation mu limit equals to 0.138 FCK into BD square. This equation is given in SP16, page number 10 and table number C. So, FCK is given as 20, B is given as 300 and small d effective depth is given as 550. So we will put all these values in the same equation. So 20 into B is given as 300 into 550 square. So after solving the values we will get 250.47 into 10 raised to 6 Newton into mm. So here the moment capacity is 250.47 into 10 raised to 6 Newton into mm. Now we will check whether the beam should be designed as singly or doubly. So here mu 400 into 10 raised to 6 Newton into mm is greater than MU limit, that is 250.47 into 10 raised to 6. Hence, we have to design the beam as doubly RC beam. And we know the equation for the auxiliary section MU2 equals to MU minus MU limit. So value of MU is 400 into 10 raised to 6 and value of MU limit is 250.47 into 10 raised to 6, which will be equals to 149.53 into 10 raised to 6 Newton into mm. So we had calculated the value of mu2. This value will be helpful while calculating the value of ASC. Now we will go for next step. Now in the next step we have to find the value of FCC and FSC. Both values are unknown for us, hence we have to calculate this value. Now we know that FCC equals to 0.446 FCK. This equation is given in SP16 and on page number 13. So we will input the value of FCK as given in the statement as 20. So we will get the value of FCC as 8.92 Newton per mm square. So by this way, you have to calculate the value of FCC. Now we have to calculate the value of FSC, and hence for FSC, we know that we have to first calculate the ratio of d dash by d. So d dash is given as 40 mm for compression cover and small d is pi phi 0. So the ratio of d dash by d will be equals to 0.073, which will be approximately 0.10. Now the value of FSC can be calculated using d dash by d equals to 0.10 by using SP16, page 13, table number F. So you will get the value of FSC for d dash by d 0.10 as 353 Newton per mm square. This method or this step we had already done in the analysis portion. Now, as we got the value of FCC and FSC, now we have to find the value of ASC. So our next step will be to compute ASC. And for ASC, one equation is given in IS 456 2000, that is mu minus mu limit equals to, this is nothing but mu2, mu minus mu limit, so equals to FSC minus FCC into ASC bracket d minus d dash. This equation is given in IS 456 2000, page number 96, clause G 1.2. But remember, on this page, the value of FCC is neglected in IS code. But we have to consider the value of FCC as we had also calculated earlier. So now, putting the values of mu minus mu limit mu2 that we had calculated in the first step here. Mu2 equals to 149.53 into 10 raised to 6 Newton into mm. So we will put the value of mu2 as 149.53 into 10 raised to 6 equals to value of FSC we had calculated as 353 and FCC as 8.92. So here value of FSC as 353 minus FCC 8.92 into ASC, as we have to find the value of ASC into D. Small d is given as 550 and d dash is given as 40. So after solving this equation, we will simplify more. 149.53 into 10 raised to 6 equals to 17548 ASC. Therefore, ASC will be equals to 852.11 mm square. This is nothing but area of compression reinforcement, that is ASC. Now we will go for AST, and as we know that we have to check the value of PT limit using the given grade of steel and concrete and value of AST2 using the IS 456 2000. So firstly we will find AST1. For AST1 we have to use the given data, that is for FCK equals to 20 Newton per mm square and Fy equals to 415 Newton per mm square using SP16, page number 10, table E. We will get the value of PT limit as 0.96%, or you may use the equation PT limit equals to 19.82 into FCK by Fy. We had seen this equation in our introduction portion. So 19.82 into value of FCK as 20 and Fy as 415, you will get the value of PT limit as 0.96%. These both values will remain same. Either you may use this equation or you may go for SP16 page 10 table E. Whatever will be preferable from your side. Now, as we get the value of PT limit, so we'll use the equation AST1 equals to PT BD by 100, and value of PT will be 0.96 into value of B as 300 and value of D is given as 550 divided by 100. So we will get AST1 as 1584 mm square. Now we achieved the value of AST1. Now we have to find the value of AST2. So we will calculate AST2. Now for AST2 we have to use the IS 456 2000, and in the previous theory also we had seen that what is AST1? Area of tension reinforcement required for a balancingly RC beam, and AST2 is area of additional tension reinforcement. So AST2 will be equals to FSC minus FCC into ASC upon 0.87 Fy, as this equation is given in IS 456 2000 page number 96, and in this equation that is given in IS code, the value of FCC has been neglected, but we have to consider the value of FCC. So after putting the values in AST2 equation, that is FSC we had obtained as 353 minus FCC as 8.92 into ASC 852.11 upon 0.87 into Fy as 415. So after solving the above equation, we will get as 812.0 mm square. So here value of AST2 for is 812 mm square. Now we will get AST as AST1 plus AST2. AST1 is nothing but 1584 and AST2 is 812. So value of total AST will be 2396 mm square. So this way you have to calculate the value of AST1 and AST2. From values of AST1 and AST2, you will easily achieve the total tension reinforcement for doubly RC beam, that is AST. Now, as we had calculated the values of ASC over here and AST over here, we have to provide the reinforcement. Hence, to provide steel or reinforcement as AST we obtained earlier as 2396 mm square, and value of compression reinforcement as 852.11 mm square. Now, for both these values, we have to use SP 16 page number 229, and from this page we will provide 5 numbers of 25 diameter bar having total AST as 2454 mm square, and for compression reinforcement we will provide 3 numbers of 20 dia bars giving total ASC as 942 mm square. So by this way you have to design the area of tensile and compression reinforcement, and finally we have to just plot all the details in the cross section of the beam. So this is the way how to calculate the area of tensile and compression reinforcement. Now we will go for the second example. In the example, it is given that design for tensile and compressive reinforcement for RCC beam 250 mm wide. Here width of the beam is given as 250 mm and 500 mm deep overall, means here overall depth capital D is given as 500 mm. to resist affected movement of 300 kilonewton into meter, and effective cover on both sides is 50 mm. That is, in tension, near tension reinforcement it is 50 mm, and near compression reinforcement it is 50 mm. And we have to use M20 concrete and Fe415 steel grade. So here we will just write the basic data. FCK is given as 20 Newton per mm square, and Fy is given as 415 Newton per mm square. And here 500 mm deep overall is given. Hence, we have to calculate the effective depth. So for effective depth, small d will be equals to overall depth minus effective cover. So the overall depth is given as 500 and the effective cover is 50 mm. So we will get small d as 450 mm. Now the moment is given as mu equals to 300 kilonewton into meter, which will be equals to 300 into 10 raised to 6 Newton into mm. Now we will find mu limit, limiting moment. For Fe415 grade of steel, we have the equation mu limit equals to 0.138 FCK BD square. This equation is given in SP16, page number 10, and table number C. So, after putting the values of FCK as 20, value of B as 250, and value of small d, that is effective depth, as 450, we will get the value of mu limit as 139.72 into 10 raised to 6 Newton into mm. Now, we will check whether the beam should be designed as singly or doubly RC beam, and for that we have to check whether mu is greater than mu limit or not. And here value of mu, that is 300 into 10 raised to 6, is greater than mu limit 139.72 into 10 raised to 6. Therefore, the beam should be designed as doubly RC beam, and hence mu2 will be equals to mu minus mu limit, that is value of mu is given as, sorry, given as 300 into 10 raised to 6, and we had find the value of mu limit as 139.72 into 10 raised to 6. So we will get the value of mu2 as 160.28 into 10 raised to 6 Newton into mm. This value will be helpful for us while calculating the value of ASC. Now, we have to find the value of FSC and FCC. So, FCC and FSC, we have to find both the values. And as we know that FCC equals to 0.446 FCK. This equation is given on page number 13 in SP16. So, after putting the values of FCK as 20, we will get the value of FCC as 8.92 Newton per mm square. Now, as we know that for finding the value of FSC, we have to find the ratio of d dash by d. So, d dash by d will be equals to, the cover on both sides is 50, so 50 upon small d effective depth is 450 which will be equals to 0.111, approximately equals to 0.15, and from SP16, page number 13, table number F, using d dash by d equals to 0.15, and using this code we will get the value of FSC will be equals to 342 Newton per mm square. Remember one thing, here value of Fy is given as 415 Newton per mm square. So we had obtained both the values of FCC and FSC, which will be helpful for us while calculating the ASC. So now we have to find the value of ASC, and while calculating the value of ASC, we will use the equation mu minus mu limit, which is nothing but mu2 equals to FSC minus FCC into ASC into D minus D dash. This equation is given in IS 456-2000, page number 96, clause G 1.2. So, as we obtain the value of mu2 as 160.28 into 10 raised to 6 Newton into mm, we will put these values, and we had obtained the value of FSC as 342 and FCC as 8.92. We will put all the values in this equation. Therefore, value of mu2 as 160.28 into 10 raised to 6 equals to FSC we obtained as 342 and FCC as 8.92 into ASC unknown, and we have to find these values, and small d is given as 450 and d dash cover is given as 50 mm. Therefore, after simplifying the above equation, we will get as 133,232 ASC. Therefore, ASC will be equals to 1203 mm square. This is nothing but area of compression reinforcement. Now, we have to find the value of AST, that is area of tensile reinforcement. And for area of tensile reinforcement, we will find by AST1 and AST2. Then after summation of both the values, we will get the total area of tension reinforcement. So firstly, we will find AST1, and for this we will use FCK, that is given as 20 Newton per mm square, and Fy as 415 Newton per mm square. And using SP16, page number 10, table number E, we will get the value of PT limit as 0.96%, or you may use the equation PT limit equals to 19.82 into FCK by Fy. So you will get the value as 0.96%. Both values will remain same. Either you may use SP16 page number 13, page 10 table. Now we will put the value of PTBD by value of B is given as 250 and value of D is 450 upon 100. So we will get the value of AST1 as 1080 mm square. Now we have to calculate the value of AST2. So while calculating the value of AST2, we have to use the equation that is given in IS code, that is AS2 equals to FSC minus FCC into ASC upon 0.87 Fy. I had told you in the previous example also that in IS 456 2000, page number 96, value of FCC is neglected, but we have to include this value. So, after putting all the values in the above equation, we will get 342 minus 8.92 into 1203 upon 0.87 into Fy as 415. So we will get the value of AST2 as 1109.80 mm square. Now, the total tension reinforcement will be AST equals to AST1 plus AST2. So value of AST1 is 1080 and AST2 is 1109.80. So total tension reinforcement will be equals to 2189.80 mm square. Now, as we got the values of area of reinforcement in tension zone and compression zone, we will provide the reinforcement in both the zone. So for that means to provide reinforcement or steel as value of AST we had obtained in the previous step as 2189.80 mm square and value of ASC as 1203 mm square, and using page number 229 from SP16, we may provide for tension zone two numbers of 25 diabars plus two numbers of 28 diabars, giving total AST as 981 plus 1231, which will be equals to 2212 mm square. And for compression zone, we may provide four numbers of 20 diameter bar having total ASC 1256 mm square. You may provide 4 bars in tension zone having AST greater than 2189.80, or you may distribute or you may add two numbers of 25 diabars or two numbers of 28 diabars. So by this way, you have to find the tension and compression steel area which are required in any given WRC beam using the given grade of concrete and steel. So here in the figure, that is in the given cross section of the beam, we have to provide AST as we had find the values. FSC and FCC, ASC, AST1, AST2, that is total AST, and finally we are providing the reinforcement in tension zone and in compression zone. Thank you. In the next lecture, we will go for the examples related to WRC beam, and in that example also we will design the WRC beam.